It's Monday, August 6th. I'm going to do a video about one of the deepest astronomical conspiracy theories, or for me, it's just a theory. Others call it a conspiracy theory because of the back and forth banter about a lot of things concerning the universe, the Earth, solar system, galaxy, and all. So what I'm going to do is I am going to take you on a journey. So I'll sit back, relax, chill, listen. And if you want, go ahead and timestamp and leave your comments as they come. But I do ask, maybe you might want to wait a little bit for context, just in case. So I'm not going to give anything here at the opening. I'm just going to jump right into it, start my journey, and where it ends, maybe it'll make a little sense. Okay, we're going to start with the human body, and we're going to end with the Big Bang. And hopefully it doesn't take that long. Now, let's get into it. The human body is roughly 75% water. The planet is 75% water, at least on the surface. The planet, it rotates around the sun. And what do we do on this planet? We walk pretty much in circles, don't we? Day-to-day routines, going from one place to the other, back to another, back to the place again. You know, work, school, something like that every day. But this is the evolution here. So did we evolve on the earth? Well, I would like to say yes. Just think about this. Something very simple. This connected me. This started years ago for me. So just take the top of your head. You ever look at it? Your hair cut short? Have you ever really looked at it? Just take a look at your head with the hair cut short, if you still have hair. Now, I'm losing mine, but when I look at the top back part of my head, it's a swirl. Look at the pattern, it's a swirl. It's a very loose swirl. Why would we have a swirl? I mean, when you think about it, it would have to be the Coriolis effect. Think about storms on this planet. They rotate. Every storm on this planet rotates. It doesn't matter if it's a tornado. It doesn't matter if it's a hurricane. It doesn't matter if you look up and you can see the cirrus clouds, you know, the nimbus or cumulonimbus clouds. It doesn't matter. And if it's not just that, even the oceans rotate. Even you got convection belts that without, we're screwed. Everything rotates. There's a Coriolis effect going on. That Coriolis effect in general, due to the rotation of the planet, helps us have wind. Not just the solar winds, but wind ourselves. Now, you got the human head. It swirls at the top. There's a swirl. Go check it out if you want. Think about that. Link it to a hurricane. That's the first thing I did. I link it to a hurricane. Hurricanes have an eye, or mostly thereof anyway, when they're strong enough. But even without that eye, they are rotating. They don't have a choice. The storm, before it even becomes tropical or even extratropical, it's going to rotate. But when it's a hurricane, that's my best example because I like it a lot. I like hurricanes. I don't want to really be in one, but I like the way they look. They're beautiful. They rotate. They spiral from the eye out. The eye spirals rapidly. Okay, when you go on time-lapse footage, the eye is rotating swift. It is like a top. The storms near the eye, bulky. They blot out the sun. When you look at the cameras from satellite views where they use Doppler or anything else, those cloud tops are high. They are white. They reflect as much sunlight as possible. They spin. The further out you go, what happens? It slows down. The hurricane has outflow winds. Those outflow winds protect the hurricane, but it's not just protection, it's exhaust from the heat of that hurricane. It's excess. So not only does it protect it, it also expresses the power of it. The larger these outflow winds, the stronger the hurricane, usually. usually. There's some that has very little outflow wind. They are tight. You think they're a small storm, and they are powerful. They are nightmares. It happens. Going from this hurricane, let's keep this in mind. The outflow winds, the outflow clouds, all of that, they generate storms. Usually those are where you get most of your small tornadoes. That's where it happens, because those winds are consistently turbulent. You can't get tornadoes without turbulent winds. So you got and a hurricane really is just a massive tornado, too big to move as fast as it could. That's really all it is. So with that in mind, these are usually just visuals I'm trying to give you. Hurricanes, they cool the earth. That's pretty much it. They cool the earth. Without excessive heat in the water, there would be no hurricane. I mean, that's just how they go. Without heat and cool air, oftentimes rolling off and under mountain ranges, you would not get tornadoes. Now, moving past this, let's move to something larger that looks pretty much just like it. Our solar system, our star, the sun. It sits there, it spins. All the planets around it, what do? They spin in their own way. It's not a perfect circle. It's not. Planets have weight. With this weight, the planets, when they circle the sun, they pull on the sun in their own ways. The sun, gravity, keeps the planets pretty much in check. The planet's gravity, like Jupiter, keeps all the other planets in check. Every planet works with every planet and the sun. And that's pretty much by happenstance. The sun could have just pulled everything in and been that, and that could have been it. But what happened? How did it get here? That's a good question. Our sun was born from a star that had died somewhere else. When a star explodes, that one major explosion has the ability to create other stars. Or it might create nothing less than a dark star, which others call a black hole. But let's back up to our solar system. Our sun is not just simply spinning, not just only dictating that all 8 to 9, maybe 10 or 11 or 12 planets, when you want to go into the Oort cloud, they rotate. All the planets rotate. They also orbit the sun. The sun is tugged, so it's never stationary. The sun moves, it wobbles. The sun is also stretched, just like the earth. Our equator, the earth, it expands at the equator because of its rotation. Sun is no different. Venus, Jupiter, Saturn, Uranus, Neptune, all of these planets, there's no different. What they're made of, their level of their own gravity, all of that plays a role in what they did. Because every planet, in a sense, is a hurricane. When all the debris of an exploding star sits there and some of it collapses, gravity takes place, forming a sun. That sun has an entire field to play with. That sun rotates. Its gravity immense. As it rotates, everything around it rotates. Slowly but surely it gets pulled in. And as it rotates, it bumps because particles move. If you ever seen mist and you move your hand through it, you don't just simply part the mist. No, you force some of those particles to collide into other particles. So when that happens, you might generate thicker droplets of moisture, whatever moisture that could be. When it gets large enough, that moisture is going to fall out of the air or area you're in into the floor. Or the ground or whatever, the bed of a truck, it doesn't matter. I used to play around in super dense fog at my parents' house on Saturday mornings. It and it wasn't often, maybe 3 to 4 times a year, and oftentimes that was in the winter when it's cold. So when this fog is, I mean, you could almost breathe it in, and I would just spin my hand in circles, and you could just see everything whip around. I thought that was just the coolest thing to do. But then I could see that little patches of it, little patches would form, little black patches would form and go away as it gets filled in by more fog. I thought that was awesome. My hand would get drenched. I thought it was the coolest thing to do. And despite it being 50 degrees or sometimes 36 degrees outside, I was warm. It was strange. For me back then, I didn't have an understanding of humidity and clothing, body temperature, yada, yada, yada. So as the sun spirals and collects these particles, the particles create a space, an empty space that has been filled. But the sun can only use a certain range of particles. And the most extreme range gives us our Oort cloud. That's what it gives. So inside of that cloud, the sun takes those, and the sun is like a sand grain compared to the size of the Oort cloud. It's tiny, but it's taking every piece of particle in there and whipping it around. Those particles collide into other particles. Those particles make larger particles. They become planets. They become comets, meteors, meteorites, asteroids. They become all of these things. And basically, this heat of the sun is the heat. Not only is it blasting things away, but the gravity of the sun is pulling things in. The rotation of this sun is creating, in a sense, for this Oort cloud, a Coriolis effect. Things are going to rotate. As gravity pulls things together, they will have their own rotation. It cleans up the solar system. What was just an explosion from the death of a sun, maybe two suns, who knows? But it turns out that it's just a pattern repeated. And our sun is estimated to roughly be maybe 4 billion years old or so, maybe 6 billion. Our Earth is estimated to be about 4.6 billion years old. That's pretty cool, supposedly. Just saying. It's possible that, hey, the Earth is just 1 billion years. We don't, there's a lot of dating that says 4.6. Now, with such events happening, you finally get a cleaner solar system. It's cleaner. There's far less particles. You got your planets, they're stationary, they're orbiting, and they're usually elliptical, whether they are exactly on track with the sun's path or slightly off, or even going backwards. We call it backwards, who knows? I mean, does the majority really dictate what's the norm? So we have our solar system, and no matter how far a comet goes out, it comes back. And depending upon chance, it could slam into a planet, it could slam into the sun. And if something out there has just enough gravity, just enough influence as it passes by at the right moment, that comet won't come back. Or maybe it'll take a longer trip. We'd have to see it to do it. Leaving our solar system was part of the Voyager project. I think it's the Voyager 2, I think. That's the one that's hit interstellar space. That should mean it's beyond the Oort cloud. I think that's how far out it's gone. Still sending back pictures. It just takes a long time. But it's just black and lonely out there. I mean, there's nothing. But what do we do from here? We can observe certain things like our galaxy. See, that's the next step. Our galaxy. We are a sand grain in our own Oort cloud. our Kuiper belt. We are a sand grain. So what do we look like when it comes to this entire galaxy? Remember what I said about hurricanes, how that flow, the spiral, how our hair is a spiral in pattern anyway, from the back and outwards. It all has something to do, because our galaxy, the Milky Way, is rotating. Scientists who discovered about galaxies had already suspected that galaxies were rotating. In the middle of our galaxy, they call it a supermassive black hole. I don't call them black holes. Well, sometimes I do, just a loose tongue on that. But in my head, I always call them a dark star. That was their original name. Something dark, massive, menacing out there. We can't see it, but it's monstrous. And it controls everything. It can kill anything instantly. There was a lot of fear of this, I think, about 70 years ago. Actually, probably more than that. And I can't remember who. I'm not going to look it up. I didn't want to do any of that. I did look it up before. I have done research here and there in the past, but names and whatnot. Please forgive me for this, for not citing names and whatnot. I just kind of want to take you on a journey. I didn't want to do the whole statistics, details. This person does such and such college, yada, 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 down the road, after 5 minutes of where this person came from, their accolades, then say it was a mouse. I just don't want to do that. I don't. So please forgive me, and please hang on if you can. I humbly ask. So, black holes. What were they before? That's all they were. It was they cited them as a tornado in space. Oh, it's a black funnel and nothing can escape. Light can't escape. Nothing escapes air. Everything goes in. It just goes in and never comes out. And people were afraid. And when people get afraid of something, they autonomize it. So what happens? Now the black hole takes on an identity. It takes on sentience for some reason. The black hole wants to eat everything. It has a design. It has a need. It is hungry. But wait. It's just there doing what it do. Supposing it's a long funnel that has an end point, like a tornado, but yet it's infinite. You can't do that. You can't throw a sand grain in the air and say the home is infinite, the bottom of it. No, it hit the floor, you can hear it. You can't do that. So I had, when I saw those designs and listened to those when I was a kid, I think I was about 11. I was like, something's not right. You can't, how is it endless if you have a design of it? We've seen it and we've seen what it looks like. No, you haven't. You haven't seen it. And then later you find out, whoa, okay, is it a hole? Like, is it like the portable hole in Who Framed Roger Rabbit? Because that's what they would show, a flat disc. They would show a flat disc eating everything, per se, eating. And then there was watching things, and I see, whoa, wait a minute. They're showing a breakdown of light spectrums to where this black hole is. And not only is this thing with a lot of heated gases around it, but there's beams of light shooting from it. If light can't escape, if nothing can escape, how is this happening? And in the show, they would not address it. They would not address it. That makes me doubt a lot of things when you won't address something right there in front of your face. Now, seeing that a black hole or dark star, or whatever you want to call it, it's out there. And they have discovered it at the center of our galaxy. In the middle of our galaxy, they call it a supermassive black hole. I'd rather they call it a supermassive dark star. And they say that, and if you've seen certain movies, they'll say, oh, it's a singularity. It pulls things in. It'll spaghetti string you and all this other stuff. I don't believe that. I have no trust in it. I have no faith in it. I have no belief in it. And I will not say it's a fact of anything that, I don't care if it's Neil Tyson. I don't care who it is. They do not have observational, prolonged evidence of this happening. It's easy. It's way too easy to make a claim and then come up with your own math to prove your claim, and then say, challenge my math to be wrong. Math is numbers. If you add and subtract, divide, and all these other things, no matter how deep into physics you will get, trigonometry, calculus, or anything, numbers will stay consistent. So you can't prove the math wrong. But what can prove anything wrong is evidence. Physical, observable, tangible evidence. And since there is none or are none, then making those claims is nothing less than being assertive. And that's not fair intellectually. It's not fair. Now, when these dark stars rotate, the reason they found it in the middle of our galaxy was because there are 4 suns that it is whipping around. It whips these suns around, never letting them go. At one point, the suns weren't moving. They were bright. There was 4 suns. Female doctor, well, call him doctor because not surgical, it's astrophysicist. She noticed they weren't doing anything. They're just sitting there. Okay, same business as usual. Then one day they started moving. And she was trying to clock the speed of it. They were moving too fast. They were actually moving too fast. They actually had to slow down some of the pictures just to be able to clock it properly. What could make these suns, these large suns in the center or most center of our galaxy, spin so fast? That's when that comes into play, the supermassive dark star. The gravity, yes, undeniable, but not absolute. It pulls these suns and it whips them around. What are these suns doing? They're spinning. They're spinning. And what happens when they spin? The dark star is yanking energy off of the sun. The sun's already trying to get rid of energy. It's just belching energy all the time. The sun has more explosions than we have cells in our bodies every day. The dark star feeds off this energy and pushes it out north, south, going on the galaxy itself, not earth-bound north and south. North-south based on the galaxy only. And every galaxy has their own north and south. This energy goes up. And it creates more of an event horizon per se. For me at the moment, lack of a better term. It gives it that more of a egg yolk middle, that bulge in the middle. It's not that anything is there. No, it's just that it goes up and the gravity pulls it back. This is the eye of a hurricane. So this was years ago. Years ago. And I thought, wait a minute, this was a roughly 1996, 98, something thereof. And I thought, wait a minute, if that's happening, then this means this is where galaxies come from black holes. And I don't know how to get in contact with these scientists or anything. And just because it's me, because I'm not in their elite group, if I came to them then and said, I bet galaxies are formed from black holes, they would have laughed at me and told me I don't know anything. And then they say, where's your math to prove it? You don't need, look, if somebody punches me in the face, I don't need some trigonometry major to calculate if it actually happened. I got hit, damn it. If someone gets ran over by a car, do you really need to do the math on velocity and the damage done? Can't you just say they got hit by a car and they need medical attention? I mean, just saying. Some things you don't need math for. Now, going on this, I thought about it. It took a few good years before I reached the next thought. Had to sit up. The hurricane has a center and it spins dense cloud around it. Galaxy work in the exact same way. Dark star, suns, energy. All the energy is concentrated there, but yet energy being pushed out. The center of our galaxy moves rapidly. Those suns move at millions of miles per hour. There's a movie where there's a singularity. They had to go to a planet that orbits a dark star. And they were on that planet for like 10 minutes, 13 minutes. But then when they got back, it was like 40 years or something like that. So the question was, well, not the question, but the whole thing was based on space-time, which I do not agree with. There is no observation or anything of space-time. They will say if you move at the speed of light and you travel from here to outside our solar system and come back, for you it might have been 5 minutes, but then for us it'll be like on Earth 200 years or so. Some weird thing like that. But there is no tangible evidence to show this. There is none. And for me, maybe because, hey, maybe I just can't think past my own nose in this. But time is a concept of us. It helps us how much time in a day, how much time does it take to get from one place to another. So it's always used as a measurement. And that's what time is. And in space, time is a measurement. How long does it take for light to travel from one distance to the other? So, or just, well, from one place to the other, in general, a distance. Sorry about that. Too busy reading the word Acer on my monitor. I don't know why. So, going on that, I just can't see. I just can't see if there was a black hole or we're moving too fast, how we're okay, but then everyone else isn't. That means by any means that just being in a car or on a bicycle, our age should be slowing down by some degree, some decimal point. I don't care if it's 100 trillion zeros, then one, or at least a 0.1 or a quarter of a one. Still, it should be possible. If you can go the speed of light, supposedly the speed of light, and then just 5 or 10 minutes to you could be 100, 200, 100,000 years to anyone else that's not with you traveling at that speed, then that should reflect elsewhere as well, to all speeds, to some degree. Shouldn't it? It makes sense. Cause and effect, just saying. For every action, there's an equal and opposite reaction. So it should fit. Now, when it comes to what I'm trying to say here, because there's a lot that goes into it, and I just want to give all of my thoughts on it. The black hole is definitely cooling off the universe. That's what's happening. The black hole cools off the universe. So you get a galaxy. You got a black hole, you got a few suns, or what energy is around it. This energy is hot. Okay, the dark star spins at an alarming rate. I mean, it's just spinning. It's spinning. The energy, I mean, you've got particles that can not so much gather with gravity, but can only have friction as they rub past each other. And eventually those particles are going to explode. The heat alone, hitting the right particle at the right time, which is going to happen numerous times. If, let's say it takes every 250,000 rotations, which just for this could be every 2 seconds. So let's say one is going to be a massive explosion. So every 2 seconds, you're going to have a massive explosion. And that's right there at the dark star. as these explosions happen, what happens? More energy is released. More energy is released. And this growing horizon around the black hole or the dark star, this disk of energy gets bigger and bigger. The gases that come from these explosions get dense. They get pushed together. They explode outwards. And as they explode outwards, you get the ability to create stars. And as these stars blossom, they form, they blossom, they live, they die. If they form a black hole or, dark star, then that alone, one dark star with another, that explosion is going to be on a scale that I can't even possibly try to even want to imagine. So you get all these explosions, all this heat, and each explosion is extra energy. Let's say you don't get a dark star, you only have one, but as many suns that will be produced over the millions of years, and these suns could live for billions of years around this dark star. When they explode, supernovas, gamma bursts, it doesn't matter. That energy has to get used. It's going to get trapped. It's going to get thrown out. It's going to have its own exhaust. All heat has exhaust. Just like the hurricane has its own exhaust, its outflow winds. When those winds trail off from the dark star, they can freely form a sun that can take its own, just a little bit. It'll orbit the dark star further away as the sun orbiting the dark star keeps it in check. And it just expands. Another sun, planets that might form right there at it. It might be giant rock planets, gas planets. It could be. And as they form, they get crushed, they die. Or they just stay there permanently, who knows? But it expands, and it keeps expanding, and it keeps reaching out to the point where it has outflow winds. And these winds turn into arms of a galaxy. And all these arms have suns, trillions of stars, trillions of suns exploding until it slowly starts to clean up. That's why you see a spiral galaxy, when they do their best to get what image they can of it, there are gaps. You ever notice that? All spiral galaxies look like it's a lot of dust with very almost artistically made black spots. Well, not spots, but they could be trails. Like we have our Milky Way, the arms of the Milky Way. It's a spiral, like a pinwheel. Some galaxies are just a flat disk, but it's strange. It's a flat disk with certain little black patches here and there. It's cooling the area off as they gather more dust, its own Oort clouds, trillions upon trillions of Oort clouds, and it starts to clean up. Galaxy forms from a dark star. The dark stars are out there creating, destroying, dictating. It's what they're doing. Now, that doesn't mean that every single galaxy has a dark star in it. What it means is that typically you can safely assume if you see a galaxy, there's a dark star at the heart. But it's not just that. It has to be an exceptionally strong dark star. Some dark stars are as tiny as peas. Some are as big as a human head. Some are as big as a house. Some are as big as the Earth or Jupiter. Doesn't matter. They're various size and they can affect to various degrees. Some live for a short time. Some live for probably just forever, maybe. However long that is. I mean, forever never ends. So forever. Forever, ever. Forever, ever. So that's how that goes. Now, if it spins, what have I gone over for that? When something spins, there has to be some form of what? Coriolis effect. that's what I thought about some years later, like 10 years or so later, something around there, I'm going to say safely 7 to 11 years later. And I thought, wait a minute. So are galaxies cooling off the universe? And I thought, wait, no, something's not right. Because naturally, everything is cold. Cold is natural. Heat is unnatural. Heat has to persist. Cold is just there. Without the sun, it's frigid. Like Pluto, its sister Sharon. I mean, lack sunlight, cold. You go out into space, despite our sun being there, and isn't it strange? You go far enough away from the Earth, you'll burn up as much as you freeze. Radiation is something, it's a trip. You'll burn up from radiation and freeze. You also asphyxiate. So I mean, come on, you're getting all three at one time. You asphyxiate, you freeze, and you burn up. Oh, so man, I don't know if what's a good way to die, huh? Really? So I thought something's not right. And then I'm thinking, wait a minute. If we have a Coriolis effect, if we have outflow winds, our hair is a spiral. You look at it, the pattern on the knob on top of your neck. It's a pattern. It's a pattern. So how do we understand the universe? We've got a planet called Earth. That's probably got everything that's on any other planet, just to a different degree. So just think about this. If I've said things that are super crazy, like I said, theories, conspiracy or not, just a theory, but everything would be rotating, wouldn't it? Wouldn't it? And if everything is rotating, it's spherical. If it's all spherical, just contemplate something. Wouldn't our universe, if possible, wouldn't it be spherical? Wouldn't it? Wouldn't our universe itself be spherical? What is our universe made of? What's this dark matter? What's that? I mean, is the universe a form? Just asking, just hear me out. Could the universe be a form of some kind of weird black liquid? And to say liquid is just because I have no other terms to describe what's in my head, what I'm thinking about. I'm not saying I know this. I'm saying I have all this kind of evidence or proof. It's just a thought. It's just a thought. I mean, what if the universe is some kind of dense matter that we are so small, so infinitesimally small that to us it's not a dense matter. It's loose. It's spacious. You die. You have not enough air or anything in it to survive. What if? So I'm just, that's just a what if. And when it comes to the Earth being roughly, 4 billion years old, and the sun, our sun, being about 4 to 6 billion years old, which is very possible for us, our sun and our Earth being roughly the same age. It is very possible. But how can our universe be 13.6 billion years? See, that's when I get very questionable. When they said 13.6 billion years, as they do radio waves, microwaves, and other things like that, to get as close to the center of what might have been the Big Bang. And I'm thinking, could they be wrong? Just think about this. Because see, I don't think there was a Big Bang. I don't think there was this one massive explosion and then, hey, we all here. And I don't think that. I think it's a series of maybe small to large varying explosions. And I think that these explosions slowly spread out. And I mean, when I say spread out, I mean when they exploded, they jettisoned, but not too fast. And they kept exploding around a central point. And when things explode around a central point that does not retain its gravitational pull, it has to let things go. There is no tether to these things that are orbiting it. And if these things lose their tether, then they can go wild. They are undomesticated. And they explode themselves up, down, left, right, back again. Because there's no tether. And they might have their own tethers that fade away. And as each one has new tethers that's going in what used to be a controlled rotation. I had another word in mind that I want to start with. I keep losing it. You can help me out. Right now I'm going through brain overload. I got other things in my mind, but right now focus on this. When everything explodes and expands, and there is no tether, what you get is a hurricane that keeps losing storms. The storms don't just stay around the eye. The storm floats outward. And you can see this on lots of other hurricane models and whatnot. The storms build. They slowly spread to the outside of the hurricane. They make it towards where the outflow winds can begin. And then they might branch off and die, or they form another superstorm that turns into a hurricane. And it might eat the previous one or go off on its own. Or they might cancel each other out. They might both kill each other. Or one begins to form and they merge. These things have been observed and they've happened. So, is it possible, using our galaxy, our Milky Way galaxy, where we have a dark star in the middle with suns that it will feed upon and sling around, 4 suns that sling around in harmony, not bumping into each other, that have created more suns, more energy that keeps exploding further and further out until you get these bands. You get these bands that form these spirals because as it cools, as the suns eat up the dust, as the dust clears and the spirals take more of a form, could that be how all of this started? If there was pitch black nothing, and now you have a universe where there are trillions of galaxies and each galaxy holding trillions of stars. Is it possible that we're all slowly but surely in some haphazardly form rotating around what used to be a singularity, a true singularity? Is it possible, as we are, 11 or 12 light years from our galactic center? Is it possible that what they've done to calculate the 13.6 billion years is an error? Is it possible that instead of, if you take a flight from California directly to New York, your flight time in a straight line, let's say your flight time is 3 hours. Let's say that your flight time is 3 hours, but you can't do that. You have to arc it. You have to go with the bend of the planet. So your flight time might actually, it could go up or it could go down depending upon a lot of factors. Turbulence, a stop that has to be made. Maybe there's some storms in the way. You got to stop, wait it out. A lot of things can happen. There are a lot of variables out there. There are various variables. And is it possible that we've been rotating for so long? The universe could be it could be trillions of years old. And if you just use a straight line to the center, the most known center, yes, you might get 13.6. Well, 4 at first, 13.6. You might get 13.8. You might get 14 billion years. But our current galaxy, I don't think our galaxy formed that fast. I don't think so. I don't think every single galaxy, all galaxies are in clusters like storms. All galaxies are rotating something. They're floating. It seems like they're floating off. Some galaxies are coming together. Some are flying away. It's all kind of haphazard. And it's strange. I'm just saying, is it possible that our planet, 4 billion years, our sun, 4 or 6 billion years, and yet the entire universe, only 13 billion years? We'll have to go up now because it's 13.6. So 14 billion years. Hey, when it's 0.5, you go up. It doesn't seem right. It's almost like saying it's almost like saying a grandfather that is 67 years old, his grandson is 57 years old. It doesn't really make sense for it to be that. It's too close. Don't you think? The entire universe that we know is 13 billion years, and we are, not that far from half that age. That doesn't make sense. That's why I'm thinking a lot of astrophysicists just might have it wrong. It just does not. All I can say, and I know this discredits a lot of stuff that I'm saying, but it doesn't feel right. I'm 42. Wouldn't it be odd if my child was 38? I'm just saying, that would be strange, wouldn't it? So, and to go on, want to be a little more accurate. Okay, yes, I'd be 42. My kid would be somewhere around, like 18. All right, that's extremely possible. Yes. Honestly, if I had my way, my kid would be probably about 10 years younger than me. If I had my way. But I was never that lucky, and nobody was never that desperate. So, but I think that it's possible. I think it's possible that astrophysics got it wrong. I think astrophysicists have probably got it wrong. I think we've been spiraling for so long that we could be trillions of years old. We might be right next to the epicenter. We could have been one of the galaxies with a dark star that was a sun that was blown away from another towards or somewhere near going towards the center of everything. And we're seeing that now as Andromeda. That galaxy is coming towards us. Or are we going towards it? See what I'm saying? When you listen to Neil Tyson and others, you'll hear them say, yes, the Andromeda galaxy is coming towards us. It's going to collide into us. Then some will say, well, the Milky Way and the Andromeda galaxy will collide. That's best to say. They will collide because it's going to happen. And they'll tell you how, but they don't have any evidence. You got still pictures of galaxies that are doing it, but you don't see it in motion of how it's happening. So, is it possible? It's something for you to think about. That's the end of what I was thinking. That is it possible that all of this is wrong? Instead of measuring how old a storm is from the center of a hurricane, you might want to see how many times that storm has circled the center of that hurricane as it moved away from it or towards it. Or did that storm form near the outside and move towards the center? Or was it born in the center, moved to the outside, and slowly back to the center due to some other things? There are too many variables for an astrophysicist or anyone to say this is what it is. And if they come up with the numbers, just keep in mind they had to come up with the numbers. This is Cedric Kennedy for Comparative Reasoning. Thank you for listening.